Hello everyone, myself Dr. Kundu. I welcome you all to this lecture of soft computing techniques. This is the fifth lecture of module 9. Till now, we have covered lower approximations, upper approximations, and boundary regions. So, upper approximation is that suppose X is the target set and R is the set of attributes. So, you can write here the target set and the equivalence classes is not equal to phi. So, that will become the upper approximations. The lower approximation is that equivalence class is completely subset with the complete subset of the target set. So, you will get the lower approximations. And the difference between these is upper approximations minus lower approximation. This difference is known as the boundary regions. So we have learned these things. Now there is an example. So here is some objects u. So u1, u2, u3, u4, u5, u6, u7, u8 are the objects. So there is two attribute. One is this is an attribute. So two attributes are headache and temperature. And one this is attribute is flu. So here for U1, headache is yes, temperature is normal, flu is no. For U2, headache is yes, temperature is high, flu is yes. Similarly for U3, yes, very high, flu is yes, no, normal, no, no, high, no, no, very high, yes, no, high, and then flu is yes. For U8, headache is no, temperature is very high, and flu is no. So here indissimilarity relations of headache and temperature. So U1, U2, U3, U4 all are unique. But here these two U5, U7 are the same equivalence class and U6, U8 are the same equivalence class because these two are same for U5. No high, no high. And here it is very no and very high, no and very high. So these are the equivalence classes. Now there is the we got the equivalence relation. So if R equal to headache and temperature, then indissimilarity of R is this thing. So you can write it U by R. So X1 is flu, yes. So for that U2, U3, U6, U7 for flu, yes. And here the lower approximation is the subset of this thing. So U2 and U3 are the subset of that. So U and U3, U6 is there. U8 not present in the X1 target set, so it will not there. U5 is not present, so you will also not get there. So this is the lower approximations, U2 and U3. Upper approximations, these two will add U5, U7, U6, U8. So it is U2, U3, U5, U6, U7, U8. So boundary region these two, so we will get U5, U6, U7, 8. Similarly for flu, no, it is U1, U4, U5, U8. So U1, U4 completely subset of these things. This U1 is complete subset of this equivalence class. So this belongs to the lower approximations, and the intersection of these 5 and 8 is not null, so that will present in the upper approximations. Again, you will get the same boundary regions. So here in this diagram, you can write this x1 is for flu yes, x2 is for flu no. So yes, lower approximation surely in that set u2 u3, and for no u1 and u4, and this is the boundary regions. You can write it, these are the boundary regions u7 u5 u6 and u8. So these are the one examples. Similarly, try to solve another question is that, so there is a set apples with two attributes, color and size. So we can write apple is ripe or not. So here x1, x2, x3, x4, x5, x6, x7, x8, x9 are the objects. Color is red, R for red here, you can write like that. R for red, Y for yellow, and G for green. These are the color and size. This is for the color and size is that S for small, M for medium, and B for big. So these are the x1 objects. Color is red, size is small, type is yes. For x2, color is red, size is big, not ripe. So similarly, all others are there. So here you need to find that x1 means the ripe apple, x2 is not ripe. So for x1 you can write it uh, this capital X1 you can write it small x1. These are the belongs to the ripe sets, and this 5 is not belongs to the no. So these are the for ripe is no. This belongs to x2. So we need to find lower approximation, upper approximation for x1 for this x1 and x2 both. So find lower approximation x1, upper approximation of x1, lower approximation of x2, upper approximation of x2, at B is color and size. So we want to solve these questions. So here these are the indispensable relations. See here all are different. Only you will get x3 and x4 are the same. Rest all are different. So nobody is RS here. So x1, x2 RB, nobody is RB. x3 and x4 same. Then nobody is the same thing. So these are the indispensable relation of B. So as I said, the ripe apple x1, so that is x1, x3, x5, x6. So lower approximation, so you will try to find that only x1 and x5 and h6 v1 lower approximations, and upper approximation intersection non-null, so x3 x4 will be there. So boundary region is x3 x4. Similarly, try for not ripe. So x2 is not ripe. So x2 is x2, x4, x7, x8, x9. So similarly here also the totally subset you will get it. The lower approximation is x2, x7, x8, and x9, and 3 x3, x4 will be added. So again boundary region is x3 and x4. So there are some property that if X is the target set, and you know that this Bx belongs to the lower approximations. This belongs to the lower approximations, and this is the upper approximations. So here this is a property that lower approximations of some target set X is a subset of the target set, and also this target is subset of the upper approximations. If target set is null, then lower approximation is also null, upper approximation is also null, and it's a null set. If target set is U, then lower approximation and upper approximation both are U. So here is the union of X and Y set, so that is the upper approximation, so that is the union of the upper approximations. Similarly for the intersections, so intersection of the same thing, so you can write the intersection uh, xy, and lower approximation of the intersection xy is the lower approximation xy intersection lower approximation y. So there are some properties. So if x is a subset of y, then lower approximation of x subset of lower approximation of y, upper approximation of x subset of upper approximation of y. So there are some properties. So these are the properties that the lower approximations of x union y is the subset of lower approximation of x and then y. Similarly, all three things are there. So here is the lower approximations of u minus x is equal to the lower approximation of minus x equal to the minus of minus upper approximations. Similarly, these two properties are there. So basic classes of rough sets. So x is roughly B definable. B is the, you can say X is a target set, B is the set of attribute. So X is roughly B definable if and only if lower approximation is not equal to null set and upper approximation is not equal to the total set of objects, that is U. X is internally B undefinable if the lower approximation is the null set and upper approximation is not equal to the total set of objects. X is externally be undefinable if and only if lower approximations is not equal to the null set and upper approximation is equal to the total set of objects. X is totally be undefinable if and only if the lower approximation is null set and the Upper approximation is the total set of objects. So U means the set of all objects. Set of all objects. So here a rough set can be also characterized numerically by the following coefficient. That is alpha bx equal to the lower approximations bx cardinal number of that, and you can write that the cardinal number of upper approximation. So alpha bx is called the accuracy of approximations, where this x, I mean the you can write that this denotes the cardinality of x. Obviously that this alpha bx lies belongs to 0 to 1. If alpha bx equal to 1, that case these two will be equal to same, so there is no boundary, so x is become a creep set with respect to b, since boundary region is a null set. Otherwise alpha bx less than equal to 1, x is a rough set with respect to b. If it is not equal to 1, so 0 to 1, then x is a rough set with respect to b. So question is that find accuracy of approximations of all previous examples. So in the all previous examples we have calculated B lower approximations, we have calculated the upper approximations. You need to find only these things. Alpha bx, you need to find only that alpha bx equal to cardinal number of these lower approximations divided by cardinal number of upper approximations. So you solve all previous example, find the accuracy of approximations. Now there is a question that there is a table. So there is some a patient P1, P2, P3, P4, P5, P6. This is attribute is three attributes: uh, headache, muscle pain, temperature. So these are three symptoms. And flu, this is an attribute. So some yes, sometime no. So for P1, headache is no, muscle pain is yes, temperature is high. So flu is yes. For patient P2, headache is yes, muscle pain is no, temperature is high, so flu is yes. For P3, headache is yes, muscle pain is yes, temperature is very high, flu is yes. For P4, that headache is no, muscle pain is yes, temperature is normal, and flu equal to no. For P5, headache is yes, muscle pain is no, temperature is high, flu is no. For P6, headache is no, temperature is very high, muscle pain is yes, flu is yes. So what I'm going to tell you that try to find indiscriminate relations of the attribute headache. Find indiscriminate relations of muscle pain. Similarly, find temperature of that. Then you try to find the indiscriminate relations of headache, temperature, etc. And also find the lower approximation, upper approximation for the target set flu yes and flu no. For headache, temperature, so these are the something you try to practice your own. And suppose X is the target set for flu yes, then try to find the lower approximations, upper approximations, accuracy of approximations, etc. So now we'll solve this question. So this is the table. So now here that let x equal to a target set x equal to flu yes. So x is equal to the flu yes for that is P1, P2, P3 and P6. If you go back you can see P1, P2, P3, P6. So induced let B is the attribute sets. So here B is headache, muscle pain, temperature. So here you can see that headache, all three symptoms we have taken. So all three symptoms is that here you will find that all three symbols. So only you will get these things, that this is no yes high separate, yes no high, yes no high. So P2 and P5 are the same. I think rest will be the rest will the unique. So here the indissociative relations with respect to B, you can write it also as U by B. So that is P1, P2, P5, P3, P4, P6. So here lower approximation of target set, yes. So see here P1, P3, P6 completely subset, and as P5, and this is not a subset of the target set. So here you can find this is the lower approximations, and in upper approximation we will add these two elements P2 and P5. So this is the upper approximation. So this is not equal to 5 and this is not equal to the total set of objects. So you can say X is roughly beta definable. So here the accuracy of approximation is this is 3, this is 5, so 3 by 5. So it means that the set X can be characterized partially employing symptoms, that is or attributes of headache, muscle pain and temperature. Similarly, take only one symptom, that is headache. So in disability relation of headache, you can find here that headache. So this P1, P4, P6 and P2, P3, P5 are the two equivalence class you will get here. And flu yes is P1, P2, P3, P6. So none one of the subset of that. So here you can write that this equivalence class XP is not completely subset of the target set. So lower approximation is null, and upper approximations you will get the total set of objects. So here we get the lower approximation is the null set and upper approximation is the set of all objects, which means that set X is totally undefinable in terms of the attribute headache. That is, this attribute is not characteristics for the set X, that is flu yes. Now taking a single attribute B equal to temperature. In this reliability B, that is U by B. So here temperature. So check the temperature. So table is that temperature is, so here it is P1, P2, P5 and P3, P6 and P4 is unique. So here this is the temperature. P4 is unique. So P1, P2, P5, P3, P6. So same set is flu X, yes. So X is set flu X of yes. So X is set of for flu is yes. So you'll get P1, P2, P3, P6. So lower approximation, take the subset of these things. So you will get here P3 and P6 and upper approximation. So obviously this will include. So upper approximations, these three include P1, P2, P5. So P1, P2, P5 and P3, P6. So this is the lower approximation, this is the upper approximation. So our boundary region is P1, P2, P5. So accuracy of approximation, that you can write alpha Bx, that is equal to the cardinal number of lower approximation 2 and the cardinal number of upper approximation 5. So that is 2 by 5. So as in this case, the lower approximation is not equal to 5 and upper approximation is not equal to the set of all objects, that is U. So X is roughly definable. However, single symptom temperature is less characteristic because value is 2 by 5 for the set X, that is flu S, then the whole set of symptoms. So here it is the value is 2 by 5, here it is the value is, you can check the value 2 by 5 is here and here value is 3 by 5. So that's why it is the temperature is value 2 by 5 to 2 by 5 and for all symptom the value is 3 by 5. So here 3 by 5. So here you can say the single symptom temperature is less characteristic for the set X with respect to flu yes than the whole set of symptoms. So here you can check, we solve it for the case of flu yes. You can also check suppose there is X2 is a set X for which flu X, flu of X equal to no. So try to solve this question with respect to these things. Try to find it with respect to the flu no. I mean you need to find that suppose B is the muscle pain, then try to find muscle pain. So try to find in the in this way. So I hope today in this class you have understood the accuracy of approximations. So find accuracy of approximations of any decision table. So you will write any table and try to find the accuracy of approximations. So these are the references of today's class. Thank you.